So we are back. New day, a new rule. Network discovery, detection. Understand how attackers discover asset in network and how to detect that activity. So we just up this virtual machine and we have prerequisite for this Zoom. Network security essentials, Linux fundamentals module. What we will learn from this one. What is network discovery? Why attackers perform network discovery? What are different types of network discovery? How network discovery technique work and how we can detect them. So whatever an attacker wants to, whenever attacker wants, they first have better understanding their target. To do that, attackers perform certain actions, discover the network. So they often perform stages that stock analysts can observe in their shift. Now here we go. First one. So attacker and network discovery. As we discussed in previous tasks, attackers start the attack by trying to discover an organization asset that are open to public accessible internet, called the attack surface. During the discovery phase, the attack attempts to ascertain some following information. What assets can be accessed by the attacker? What are the IP addresses, ports, or S services running on their assets? What version of services are running? Does any service have vulnerability that can be exploited? In short, the attacker tries to find opening whatever he can. Scanning ports, and here we have the firewall that will mess with him. Defenders and network discovery. So on the one hand, defenders are sometimes run software that performs network discovery activity. During the activity, defenders want to achieve the following goals: inventory the organization's assets and ensure all assets are documented. You have to know your network. Ensure no unnecessary IP port services is open. Whatever is running is necessary. Ensure vulnerabilities are patched, or at least the exploitable vulnerabilities are patched. The challenge in detecting network discovery. As you may have noticed, both attackers and defenders perform discovery actions. Multiple research organizations, web crawlers, search engines, etc. all perform similar discovery actions to map the resources present on the internet. SOC teams must differentiate between good and bad discovery. To mitigate these challenges, SOC teams often use the following techniques. A low list, known internet and external scanners, ensuring no alerts are triggered on these resources. Integrated threat intelligence with detection use cases and flag scanning activities only for known malicious or suspicious resources. Silent the previous point has changed to miss some malicious scanning activity. Some teams use threat intelligence to raise the severity of the alerts instead of only triggering alerts on them. In addition, they add some generic use cases to alert on scanning behavior, which will be learned in the next step. What do attackers scan other than IP addresses, ports, or versions in order to identify vulnerability in the network services? External and internal scans. External activity. SOC analysts may encounter scanning activities from outside their organization network and scan the machine inside them, mainly the public-facing assets on the perimeter. SOC analysts will observe that source IP in this type of attack is an external IP and destination IP belong to other organization. This type of scan indicates that attack is still in a reconnaissance phase in a micro attack lifecycle. The attacker does not have foothold inside the network and is doing an initial reconnaissance to identify opportunities to gain essential access to the network. So here we go. The attacker is in this stage, reconnaissance. This type of scanning is the essential phase of the attack, and the attacker hasn't yet achieved any foothold in the network. So it is low severity type of scanning. In response to external scanning activity, SOC analysts can block offending IP addresses on the perimeter firewall of the organization's network. However, we must note that the attacker may come back again by masking their addresses or switching, and by blocking you can inform him that his previous address was burned. Internal scanning activity. The other type of scanning that SOC analysts may observe as an internal scanning activity. SOC analysts will observe that the source and the destination addresses are private IP addresses inside the organization's network. This type of scanning indicates that the attacker has progressed in the discovery phase of the micro-attack cycle. In some other frameworks, it may also call internal reconnaissance, indicating the attacker has foothold in the network and is now gearing up for lateral movement. So the attacker is here. He just passed through resource development, initial access, execution, persistence, privilege escalation on some assets in the network, defense evasion, credential access, and now he's in the discovery to gain more access in the network. In this type of attack indicates that the attacker is already inside the network. It is high severity alert after ensuring this is not some unauthorized activity. SOC analyst will escalate this alert and initiate the incident response process. In this case, merely blocking the source IP on the firewall will be insufficient, and deeper investigation into the system will be required, and the root cause analysis will have to be performed. Identify internal and external scanning. Let's see what scanning activity looks like in firewall logs. In the VM machine, open terminal, navigate to where do we have downloads. Logs. Now let me see. Okay. Look. Session 1. But the JQ part is not working. It's this way. So, once we are familiar with the content of the file, we can get utility with the limiter. Different colors of the CSV file. Please note that since date contains comma, okay, we will have to calculate the comma accordingly. Let's go through these files and answer the following questions. Which file have showcase internal scanning activity? Scanning activity. So we have source, destination, rule name, method, let me see a rule name. Top. Let me see. Rip. Species symbol. Okay. We have Oracle species scan. Which file contains survive with and scan, and it is session 1. Look. Session 1. Whoa. Suspicious scan activity. Session 1. What? Look at which contains private. Back in our days, it was just hid. Oh, we have multiple types of scan, especially for PostgreSQL, potential PNC scan. And okay, this type of scans are for internet. Wait, what? The destination source. Okay. Oh, maybe movement can be reloaded. Yep. Why get something? Yep. So let me see. I want to see who names. Wait a minute. Who names? Okay. Message. Who name? Sort this one. Ping. I say ping links. Well, we have in a second in session one. And what we have in session 0. Nothing. Session 0 doesn't have any of full names. So we have here only one address, bit scans through any ports. I will bet this one. No. Oh, pause. Hold on, pause. What do we have? In a second. In the second one. Destination point. Source. Oh, we have source. How many log entries are present for the internal IP performing internal scanning activity? Oh, title activity. Ping. Disk activity. We have this IP. So grab this IP on the session 2. That's it. External. Let's perform external activity. This one there. First one. Zero. I guess this is it. That's it. Horizontal receive vertical scanning. Once the attacker know what hosts are present on the network, they often want to identify what ports are open on those hosts. This is called a port scan and can be following types. Horizontal scanning. Sometimes an attacker will scan for same port across multiple destination IP addresses. This type of scan called horizontal scan. Horizontal scans are performed to identify which port exposes which host exposes a particular port. An attacker might perform this scan if they intend to exploit a specific port. An example can be WannaCry ransomware. Some spread the network using SMB version 1. Vulnerability can be scanned for machines which have open 445 port which used for SMB. So he's scanning for 445 port on all of these hosts. Very clever. We can detect the horizontal scan in the logs if we see the same source IP single destination port but multiple destination IP addresses across multiple events. Vertical scanning occurs when the single IP address is scanned across multiple ports. Attacker perform vertical scanning to footprint a host and identify its exposed services. This activity might be performed when attacker is focused on identifying a vulnerability on single machine because they can see the vulnerable target based on their objectives. For example, if an organization exposes only a single service to the internet, any attacker who wants to breach that organization would be form first the vertical stack on that server to identify open ports and understand the services running on the machine. We can detect vertical scan in the logs if we observe same IP on the same destination but multiple destination ports across multiple events. Sometimes attacker might perform mixed horizontal and vertical scan to gain advantage of both types of scans. Let us see what we learn here. And let answer following questions. One of the log files contain evidence of horizontal scan. Which IP range was scanned? Let me find the range scanning first. Almost. Wait, what? Let me see. This one is the origin. It's like Zik. We don't have Zik here. So, trouble origin packet, origin bytes. Oh, let me see. Because the regular expression is not matching this one with the echo key. Set address web subnet. Combine all the addresses in a single subnet. I don't know. Combine all the addresses. Maybe I don't need this. So I just found in log session 2 there is this IP that is doing some kind of scan on the source. So CDR 24. Now this, in the same log, there is one IP address on which the vertical scan is performed. Vertical scan. So vertical scan, one IP, searching for many and many. Let me see which one can be. Well, I guess this is it. Yeah, this is it. This is one of the IPs that is performing. One of the IP addresses only few. Ask which common services are hosted. So I will take one of them. Wait, what? Destination port. No. Port. Let me do it. Now we have to. So let me take all of this. Which services? We have 3 services. One of the IPs only few ports. A region destination. Two. Let me see. Okay. A region port. With IDs. This machine is not respond at all. So let me see. Let me see. I'll call this one. Dude, this machine is not working at all. So we're using the hint for the third one, the fourth one. I'm not getting enter format because let me real quick copy this one. Downloads, loads. So we have this IP, and now I wanted to sort in the log session to this IP, by this IP. Let me show you. We don't have too much information in here. Now let me sort by this IP, and we have 480, 4445, and 3389. That's it. Now ping sweep. This is one of the most basic network scanning technique. Ping sweep are generally used to identify hosts present and online on a network. This scan is run by sending Internet Control Message Protocol, in short ICMP, packet to host. If host is online, it will reply with the ICMP packet of its own. However, it is often blocked by security controls, like I said. firewall is blocking this one. In some organizations nowadays, making it easier to defend this type of scanning activity. TCP SYN scan and TCP connection is initiated by three-way handshake. Following the steps SYN ACK to establish connection, network scanner can sometimes use functionality of the TCP to identify online hosts in their open. The scanner sends SYN request to the participant. If SYN ACK response is received, it means that host is online and a port on which the SYN connection was sent is also opened. This is stealthy scan that often blends in the rest of network and is harder to detect. SYN scans. UDP scan. Another way to identify online hosts and open ports is the sending usually empty UDP packet. If port is closed, host send back ICMP unreachable reply. This signifies that the port is closed, but the host is online. In some cases, scanner will not receive any response until set time is reached. If no response is received, the scanner will mark the port as open, but this is not clear evidence of the port being open. In rare cases, scanner might receive UDP packet in response, which is evidence of port being open. As we can infer, UDP scan is unreliable and slow, as it relies on waiting until it does not receive any response till the time out is reached. Most organizations overperform internal scan to check the vulnerability, keep their eyes on rogue assets, and identify any opportunities for attack surface reduction. It is permanent for SOC analysts to know the details of their scans, which add the IP address from where they run, type of scanning being performed, and any scanning schedules. Ideally, the scans should be excluded from any detection use cases of SOC aim to reduce the noise. Let's see if we can identify types of scan using firewall logs. Let me see this one. So we have a loss big changing. Let's see this one. So we have discover and unlocks the entire time range. And then we have destination IP. And then filter all destination port. This will take ages. This machine is slow, like I don't have even boards for this one. Dude. I don't know. So I just restarted this machine. Let me see. We are here. Data view looks. All looks. Now range. Search for time. Range. Okay. Now we have to see plus destination plus source okay, and now which source IP before ping swoop. Let me see. Add network protocol. Field to the columns. Filter for ICMP. Very interesting. Network protocol. Now open this one. So filter there. Protocol. I see. What the questions one? Once again, which source IP performs ping target across whole segment? Source. This is it. The ZIC con state value shows connection state. Using the information provided by this value, identify the type of scan being performed by 203 against 190. Let me see. ZIC con state. ZIC con state. This is it. The question once again. One. Connection state. So private value identify types of scan being performed. So I would destination IP destination being performed by this one against this one. So destination source IP 24, yeah. Okay, against this one. Eighth SO. Let me real quick search for the Gongon states. The other side that I just came up with. So connection attempt. Connection still not terminated. T A O T H. Nothing seen. And so on. Okay. Now this one we have S0. So we need for the sake of question identify type of scan being performed. So scan being performed is no reply. Let me real quick see what we have here. I need to sort this one. Let me check this one. Loss. Unique. Elasticsearch. Nope. This is it, maybe. Maybe this is it. So by the time it's loading, I'm gonna cook some eggs. I guess SQL query maybe will point to the things I need. I guess name. Okay. Where where in here? Okay. Zik on state selector. Is value. And Zik on state. I don't know. So just got this one. In here we have breakdown, and if I'm breaking down this concon state, we have only one value, S0. That 0 is attempt, no reply. Connection attempt seen, no reply. So this one is I guess we have seen scan in here. That's it. Is there any UDP scan attempts in the logs? Let me check real quick. Do we have UDP in here? Nope. Do we have UDP in here? Okay. So we got some. So we got this one. No save, petition, connection. And we got all RSTO, RST, this one, reset, connection established, originated, and rewarded. No, we don't have. Nope. So, we just got this one. What is the network discovery, difference between external and internal scanning, and severity on each. Port scanning and host scanning, and why each of these performed. How different type of scans are performed at more granular level. So that's it. So long. Thanks for having us.